Hello everyone. In the previous video, we have seen about the outline of placement preparations for ECE students and the basics of logic gate and basics of multiplexer. In this video, we are going to discuss about demultiplexer. A demultiplexer is a combinational circuit that has one input line. The demultiplexer has one input line and 2 power n output line. This is just opposite to the multiplexer. In multiplexer, we have seen that it has 2 power n input lines and 1 output line, whereas in demultiplexer it has 1 input line and 2 power n output line. The demultiplexer is a single input and multi-output combinational circuit. The information is received from a single input line. The information is passed through to demultiplexer through a single input line which is directed to the output line. On the basis of the value of the selection lines, similar to the multiplexer, in demultiplexer also the output depends upon the selection input. Depends upon the selection input, the input value will be connected to any one of the output line. The input will be connected to one of these output line. Demultiplexer is opposite to multiplexer. Demultiplexer is one to many, whereas in mux is many to one. In demultiplexer, we have one input and 2 power n output, whereas in multiplexer, we have 2 power n input and 1 output. First one is 1 cross 2 demultiplexer. In 1:2 demultiplexer, there will be 1 input and 2 output. For 2 could be represented as 2 power 1. Here the value of n is equal to 1, so there is only one selection input. Depending upon the selection input, the input A will appear either in y1 or y0. When the selection input S is not equal to 0, when the selection input S is equal to 0, the input A will appear across y0. The input A will appear across y0. When the selection input is not equal to 1, the input A will appear across the output y1. This is the truth table of 1:2 demultiplexer. This is the Boolean expression. Since there are two outputs, we need to write two Boolean expression. For the output line y0, this is the expression. The output y0 will appear when the selection input s0 equal to 0. 0 is represented as a complement term, so s0 bar into the input A. For y1, the output y1 will appear when the selection input s0 equal to 1. So y1 equal to s0 into A. This is the Boolean expression of 1:2 demultiplexer. Then the logic diagram. This is the logical diagram for 1:2 demultiplexer. The first output y0 is obtained by using this AND gate. S is passed into an inverter to get S0 and A is passed to the AND gate. Both the S0 bar and A is passed to the AND gate to derive the y0, and S and A is passed as input for the another AND gate to derive the expression for y1. This is the logical diagram for 1:2 demultiplexer. Next one is 1:4 demultiplexer. It has one input and 4 outputs. 2 power 2 outputs are there in 1:4 demultiplexer. The value of n is equal to 2. Since we have written, we could write 4 as 2 power 2. The value of n is equal to 2. So there are two selection input. Depending upon the selection input, the output A will appear across any one of these. The input will appear across any one of these output line. When the selection input S0 and S1 both are 0, the output will appear across Y0. The applied input will appear across the output y0. When the selection input S1 equal to 0 and S0 equal to 1, the applied input will appear across y1. When the selection input S1 equal to 1 and S0 equal to 0, the applied input A will appear across the output line y2. When both the selection inputs are equal to 1, the applied input will appear across the output line y3. We could interpret this in the decimal form. 0, 0 could be represented in the decimal form as 0, so the output will appear across y0. For this, the decimal number is for decimal equivalent of binary 0, 1 is 1, so the output appear across y1. The decimal equivalent of 1, 0 is 2, so the output appears across y2. The decimal equivalent of 1, 1 is equal to 3. So the output appears across Y3. This is the Boolean expression for 1:4 demultiplexer. There are 4 outputs Y0, Y1, Y2 and Y3. The expression for the output Y0 is equal to, S1 bar S0 bar into A. The output Y0 will be A when both the input S1 and S0 are 0. So S1 bar into S0 bar into the input A. The output y1 will be equal to 1, y1 will be equal to a when s1 equal to 0 and s0 equal to 1. So s0 is given as a simple This is the Boolean expression for 1:4 demultiplexer. For the 1:4 demultiplexer, there are 4 output lines Y0, Y1, Y2 and Y3. The input A will appear across Y0 when both the selection inputs are 0. So both the terms are written in complement form. The input A will appear across Y1 when S1 equal to 0. So S1 bar into S0. S1 equal to 1. The input A will appear across Y1 when S0 equal to 1. So S0. The input A will appear across Y2 when S0 equal to 0. So S0 bar and S1 equal to 1. So S1. The input A will appear across Y3 when both the inputs are 1. So S1 and S0. This is the logical diagram for 1:4 demultiplexer. There are 4 outputs Y0, Y1, Y2 and Y3 and input A and 2 selection input S1 and S0 bar. Y3 is derived for this AND gate. 3 inputs are given. One is A for Y3, A, S0 and S1. A, S0 and S1 are given as input for Y3 to obtain Y3. For Y2, one AND gate is used, and for this AND gate, 3 inputs are given. One input is A and one selection input S1 and one more selection input S0 bar. The S0 bar is obtained by using an inverter. Similarly, other 2 outputs are derived. This is the design of 1:4 demultiplexer using 1:2 demultiplexer. This is the truth table of 1:4 demultiplexer. There are 2 selection inputs S0 and S1. D is the input given and 4 output Y0, Y1, Y2 and Y3. We have 4 output lines. To get 4 output lines, we have used 1:2 demultiplexer in the two 1:2 demultiplexer in the second stage, and to channelize the input to any one of these 1:2 demultiplexer, we have used one more 1:2 demultiplexer in the first stage. The input D is given to the first stage of 1:2 demultiplexer. Let us analyze this circuit. When S0 equal to 0, if S0 equal to 0, the applied input D will appear across this line. When S0 equal to 1, the applied input will appear across this line. So let's from this truth table we could analyze the circuit. When S0 equal to 0, the input will appear across this line. D will appear across this line. When S1 equal to 0, the applied input will appear across this output line Y0. So when both the inputs are 0, 0, the input will be supplied to this output line Y0. When S0 equal to 0 and S1 equal to 1, the output will appear across this line Y1. The applied input will appear across this output line Y1. When S0 equal to 1, the applied input will appear across this line, and when S1 equal to 0, the applied input D will appear across this line Y2. When S0 equal to 1 and S1 equal to 0, the applied input D will appear across the output line Y2. When S0 equal to 1 and S1 equal to 1, the applied input D will appear across this output line Y3. Thus, we have designed an 1:4 demultiplexer using 1:2 demultiplexer. To derive 1:4 demultiplexer using 1:2 demultiplexer, we need 3 1:2 demultiplexers. Now we are going to realize 1:8 demultiplexer using 1:4 and 1:2 demultiplexer. This 1:2 demultiplexer is used to supply this input A either to this demultiplexer or to this demultiplexer. If the selection input S2 equal to 0, the applied input will appear across this line. When the selection input S2 equal to 1, the applied input A will appear across this line. So let us realize this circuit using this truth table. When S2 equal to 0, the input A will appear across this line. When S1 equal to 0 and S0 equal to 0, when both these S1 and S0 are equal to 0, the applied input A will appear across this output line Y0. The decimal equivalent of 0, 0 is 0. So the applied input A will appear across this output line Y0. When S2 equal to 0 and the another two selection inputs are 0 and 1, this for decimal equivalent of 0 and 1 is 1. So the output appear across the output line 1. The decimal equivalent of 0 and 1 is 1. So the output appears across the output line Y1. If the selection input S2 equal to 0 and the other two selection input are 1, 0, the decimal equivalent of 1, 0 is 2. So the output appears across the line Y2. When the S2 equal to 0 and the other two selection inputs are 1 and 1, the decimal equivalent of 1 and 1 is 3. So the output appears across the line 3, appears across the output line Y3. When S2 equal to 1, the applied input A will appear across this line. When the other two selection inputs are 0, 0, the output will appear across Y4. If it is 0, 1, if the output will appear across Y5, and if it is 1, 0, the output will appear across Y3, and if it is 1 and 1, the output will appear across Y7. If all the three selection inputs are 1, the output will appear across Y7, and if all the three selection inputs are 0, the output will appear across Y0. Thank you.